That's it. I give up. I give up. It's 5:43 in the morning. I have not gotten any sleep. I am out of my mind. The music's back, by the way. I think if I decide that I want music in this video this time, maybe I will. Maybe it'll be pop. Maybe it'll be jazz. Who knows? Maybe there's no music at all. It doesn't matter. All right? I have a coffee, freshly brewed, because I figured, why not? It's not like I'm sleeping anyway. I have a Monster. I don't know what for, but, it doesn't hurt. I thought I would get some work done. So at around 2 or something in the morning, I was data cleaning. I'm not sure why that's relevant to anything. Nothing I say is relevant to anything anymore. All right? And just so we're clear, just to get this out of the way before I continue, I'm not sulking over my heartbreak anymore. All right? I deleted Line. I deleted Instagram. I effectively burned that bridge to any further heartache. All right? So I'm fine. I'm doing great. I'm doing I got coffee and Monster in front of me. All right? What more could I ask for? Okay, I think that's out of my system. In the last video, we finished with these data points that have now been cleaned. And so really our next move from here is finding how can we best plan a route around these points. What's the word? Oh man, I've lost it. Let me just do that whole part over again. Oh, this is such a mess. Oh, I'm at such a loss for words here. Solutions, interpretations are subjective. Did that work? Okay, okay. You know what? We're looking at a map of Japan. Japanese. Boom! That's it. That's all I need to say. All right, moving on. So, where I took the direction of my solution is if we look at all of these data points, I figured the best way to traverse as many prefectures as I can is to look for the density, the highest area of density of all of these points. And when I say that, you might initially think of something like a dot density map, Feels pretty intuitive, it's in the name, but guess what? That's not what I did, alright? What I did is I took all of these points and I used a tool called a Delaunay triangulation. So we take this layer, this point layer, and we throw it up here. And it's going to look like this. Now, I'm not going to explain in detail what this mathematic process is, aside from the fact that it takes all of your data points and it puts lines between them and it makes triangles in the center. That is probably the worst explanation I could have given. If you want to learn more about these specific spatial geographic computational algorithms, you can absolutely do that, but this is not the place where it's going to happen. One thing that I can say about this specific process is that it has a tendency to avoid very narrow triangles. So particularly, and this is not a great example, a triangle like this, very, very long one, is more an exception to the rule than it is the rule itself. More often than not, you'll be looking at wide triangles like these. And so why that is important to my process is because I figured the best way to find the closest points would be to triangulate all of the points and then find the smallest triangle, because the smallest triangle would have 3 points in close proximity. So we've done the process that we did last time, which was calculating the area of each shape, and we should be familiar with that process. And so I'm just going to go ahead and filter down here. I'm going to select 1, and let's zoom into that selection. And you'll see it pulls up this very small narrow triangle. And just to make this easier to see, I'm going to pull the opacity down to 50. Boom. And so this is still the same map. And you can see this triangle over here is very small. And the reason it's small is because these 3 points are very close together. This is kind of where I begin doing my calculations manually. I very well could import a road map onto here, or transportation networks, and start doing network analysis, but that's kind of beyond the scope of this question. I have, at this point, achieved the result that I wanted. I found these 3-way boundary points, and I found the prefectures that surround them. This one's not actually included, but I am going to include this just because it is relatively close to these 3 points. This seems like quite a long walk, but even these 2 points among themselves have 1, 2, 3, 4, and look more than doable in terms of within walking distance, and we'll have to see whether or not that is feasible. But yeah, again, interpretation, analysis, at this point, it is very subjective, and I'm looking not only at the data, but putting into question my own physical abilities. This is something that I have to walk, and so any constraints that I'm putting here are not purely mathematical, but to a large degree up to my own willpower. You know, can I really walk this distance? Can I really do anything? And so at this point, I might actually just bring this over back to Google Maps and look at the area. And there's one thing here specifically that I'm looking at. Vectors are nice, but if we're comparing this area to kind of, I think it was this area, if we're comparing these 2 regions of Japan, just off the top of my head, I am already familiar with the fact that Tokyo is walkable. I mean, it has to be. A lot of roads and cement, you know, urban area. Urban area. This area over here, Wakayama and kind of Mei and Osaka and the rest of these prefectures, potentially not as urbanized. Spatially, sure, this doesn't look like that far of a distance. Actually, there is a measuring tool in GIS, at least there should be in most all of them, like 26 kilometers. But 26 kilometers of walking through city, or 26 kilometers of trekking through mountain and forest, right? The type of information that we don't have right now. So really, at the final stage of this planning process of interpretation, we need to consider factors beyond purely spatial aspects. So let's do that.